problem where we're trying to find the pressure of individual gases in a container. Alright, so the first thing is that you're going to need to know this equation here. You can find it on your formula sheet for AP Chemistry. It's found on that sheet. And basically what it says is the pressure of the gas that you're looking for, the partial pressure of that gas, is equal to the total pressure times the mole fraction of the gas that you're looking for. So X of A is the mole fraction, which basically equals the moles of A, the gas that you're looking for, divided by the total moles in the container. So let me show you how to do a problem like that. So we want to find the partial pressure of each gas, so let's start with pressure of H2. So we'll go pressure of H2 equals the pressure total, which is 2.9 atmospheres, and we're going to multiply that times the mole fraction of the hydrogen gas, and so we have 2.5 moles of hydrogen, so we're going to take 2.5, and I just put this like in a big parenthesis here, and we're going to take 2.5 and we're going to divide that by the total moles in the container, which will be 2.5, that's the hydrogen, plus whatever other gases, in this case it's just helium, so 3.2, and you'll probably want to put little parentheses around that, I guess. And if you do that, that should tell you the pressure of the H2. So how I do it is I would take 2.5 and divide that by 2.5 plus 3.2, and that ends up being 0.44 when you do that. So then you're going to take 2.9 times this, which is 0.44, and so you would get that the pressure of the H2 equals 1.3 atmospheres. And then you would want to do it for the helium, so you'd go pressure helium, and that's going to equal the total pressure again. Alright, so pressure total, which is 2.9 atmospheres. You're going to multiply that by helium's, the number of moles of helium, which would be 3.2, and you're going to divide that by 2.5, which is the total number of moles. So you're taking the moles of helium divided by the total number of moles, and if you do that, that equals 1.6. Now one thing that I always do at the end when you're trying to do one of these is if you add up, according to Dalton's law of partial pressures, the partial pressure of each gas in a container equals the total. So 1.3 plus 1.6, does that equal 2.9? And if you add them together, it does equal 2.9 atmospheres. Okay, so that's one type of problem where you're given moles and you're trying to find the partial pressure of each. A second type of problem is where they don't give you moles, but they give you some other unit, such as grams. And so the thing that you'd have to do is say, well, hey, I could use that equation with moles in it, the mole fraction, but first you got to change to moles. So you'd have to just start off with 23.6 grams of hydrogen. Remember that hydrogen is H2, and change that to moles. So 1 mole of H2 is equal to roughly 2 grams H2. And so if you do that math, you get 11.8 moles of hydrogen gas. Then you'd have to do the same thing with the carbon dioxide. So 65.8 grams of CO2. And you'd have to change it to moles. So 1 mole of CO2 roughly equals 44 grams CO2. And that equals, let's see, around 1.50 moles of CO2. Now, once you know the moles, it's just like the last problem. So you take the pressure to get the pressure of whatever gas that you want. So let's say H2. We're going to take the total pressure, which is 1.5, and we're going to multiply that times the mole fraction. So that's going to be of hydrogen, so it'll be 11.8 divided by 11.8 plus 1.50. And if you do that, you get that the pressure of hydrogen is equal to 1.33. Then you could do the same thing for the CO2, so that you're going to take the total pressure, 1.50, and you're going to multiply that times the mole fraction of the hydrogen, or the carbon dioxide, which is 1.50 divided by 11.8 plus 1.50. And so that's going to give you the pressure of the CO2, and if you do the math there, let's see, that ends up being around 0.17, and these are both atmospheres. And so then if you add that together, 7, 10, 3, 4, 5, so that's going to be about 1.50, which is the total pressure of our container that we started with. So that's how to do a problem like that. So now there's a worksheet that I gave you guys to do when the sub's there, so now you should try to do that worksheet. See you later.